Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of attributes of quadratic function graphs. This is standard A.7A in the great state of Texas, and we are using item number 40 of the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have an equation here, and we need to find the best graph that represents this equation. Now there's a long way to solve this if we don't know factored form, and then I'll show you how this can be solved in about 20 seconds with factored form. But let's say we don't know what factored form is. That's the form that we're looking at right now. So we have one trick, and it'll work. If we can get this into standard form, we can find the axis of symmetry, and then we could use that to actually find the y-coordinate and find the vertex. So that works. So what do we need to do here? Well, we need to multiply these binomials here. X plus 1, x minus 3. All right, so we're going to FOIL this out here. Right? First, outer, inner, last. So the first values are x squared. And then the outer is x minus 3, so 3x. And then the inner are just plus 1x. And last is 1 and negative 3, negative 3. Okay, so let's see. We just need to go ahead and combine like terms. Let's put the h of x back in there. So it's x squared plus 3x minus 1x, so that's just minus 2x minus 3. All right, now that I have it in standard form, right? Standard form looks like this. Ax squared plus bx plus c. We know that we can find the axis of symmetry, right? That's the magic line that you can draw on any parabola here that will cut it exactly in half. We don't know which of these are going to be correct. So let's see the axis of symmetry. This is on your mathematics chart or your reference materials, and it is x equals negative and then b over 2a. So that's why our standard form is so powerful, because our b, right, so our b equals, it's right there, negative 2. Our a is right there. There's nothing there, so we can always assume it's a 1. Since it's an x squared rather than a negative x squared, right, we can assume it's a positive 1. Okay. So it's negative b, so that's negative 2, and then 2a, 2 times 1, so that's going to be negative, and then negative 2 over 2, so that's going to be negative over with negative 1. These two negatives are going to go ahead and make a positive, so 2 over 2. Okay, so my axis of symmetry is x equals 1. Right, so I see this right here. F has got an axis of 1. This is x equals negative 1. This is x equals 1. And this is x equals negative 1. All right, so I can get rid of j, get rid of g. But I've got two different ones here, h and f, that could possibly work. But you notice their y values are different for the vertex. I really need to dig into that vertex. Well, I'm just going to plug this x equals 1 back into this original equation, right? So let's just say h of x equals, and then I'm going to plug the 1 back in, 1 plus 1, and then 1 minus 3. So that's going to equal 2 times negative 2. So h of x, when you've got h of 1, then your h of 1 equals negative 4, all right? And we see that negative 4 right there on f. So f is looking pretty good. Now, what's the simpler form? Is the factored form, right, is h of x equals x minus u, x minus v. And the v and the u they're zeros. So in order for this u to be a positive 1, that's going to have to be a negative 1. And for that v to be negative 3, you can just put 3 right there. These are your zeros. So our answer here is F.